Hello everyone. In the last class, we implemented using templates the route redistribution between OSPF and OM. Today, we will do another redistribution between EIGRP and OM protocols. Then we will introduce the redistribution mechanism between OM and traditional protocols. For EIGRP, we choose to do on the edge of DC2. On the edge of DC2 too, there's a called VPN tag of 10, or to say, from the router's perspective, in the VRF of the device with VPN tag 10, we implement it. Due to the large number of our devices, we select the CHDC and CSR1K running EIGRP to focus on. We use port 3 to connect. This is the address plan 40.6 and 40.7 subnet. We will announce the 11th subnet as EIGRP. Next, switch to our experimental environment. We will use a template. Which one? Find DC2 here. chedit template. The device's VPN implements ERP editing in VPN 10. Add create template name EIGR. PDC2. Basic information we assume ERP's number is globally fixed. A static value. Interface in our previous diagram, we used 3. Globally enabled. No address summarization here. Add without authentication. Keep other default values. And another required field is the network prefix. The prefix plan is a 4.10 network. Save. Update template. To add the target interface on DC2, the interface name is port 3. Update. Check the configuration. We need to wait here. A new configuration was generated. This is the new EIGRP configuration. A series of default parameters. Interface 3 participates in EIGRP. The network announced is 4.1.0 update. S-switch during the update. Let's run it. The number is 100. announced 40.7, there was an error in the previous announcement. Add another loopback interface. We found behind the CH no neighbors, then switch to CH6. Check the EIGRP configuration. Found the network is 41. We plan 40 on CH6. Correct this error. Correct through the template. Modify the template. Edit this EIGRP template. Change network edit to 40.0. Update again. Create configuration, push configuration here, sending, in process. EIGRP neighbors appear. As before, check the current route. Our traditional router did not receive routes. You can see it's actually on. We need to enable ONP and update the template again. Redistribute, bring the ONP protocol into EIGRP. Wait for the update. There was an explanation earlier. On Edge 6, when I checked earlier, there were two errors. The first was the network announced was wrong. The second was our process was shut down. The interface participating in the process needs to be reactivated with no shutdown. Check the routes again. Okay. We received routes with a label X. These were redistributed into EIGRP through the ONP protocol. Okay, that's all for now. Here's a question we have in CH's OSPF. These are our traditional routers running OSPF protocol and ordinary OSPF, EIGRP, and such protocols. The ONP protocol actually automatically learns the traditional protocols, but traditional protocols cannot learn ONP routes. This is one of the key points we are discussing today about route redistribution. In SD-WAN scenarios, there is the ONP protocol and local protocols. In the past, for redistribution, we had single point bidirectional redistribution and dual point bidirectional redistribution. Now, we are considering a single point from local traditional protocols to ONP marked as local to ONP. Okay, the return path is ONP to local. First, let's understand the direction, then learn the first rule in the absence of defects. The OM protocol automatically learns. No, it learns automatically, but from OM to local, we need to do manual redistribution. This is not automatic. From OM to local requires manual redistribution. This brings us to a second topic. In the process of redistribution, we need to consider whether it will cause loop issues. While avoiding an excessive number of redistributed routes, these two issues need to be considered, mainly to see if it will cause loops. The first scenario is about OSPF redistribution. Please note that in our sites there are multiple C edges, and all C edges will run OSPF. Question: between two OSPF areas running, will their routes cause loops with each other? Please think about it. In fact, OSPF loop prevention mechanisms still apply. How does it work in this scenario? Please note the DN bit. In OSPF redistribution, OSPF routes are tagged with the DN bit. Prevent loops by comparing the DN bit. Remember this point. Let's look at a brief configuration. Redistributing OM in OSPF to avoid excessive redistribution. We can filter out the default by using routing policies. Not needed by default for us to announce, OM protocol will learn by default. OSPF will learn automatically. This is the first scenario. The second one is the BGP protocol. Similarly, CH devices run BGP. Will the BGP protocol form routing loops between these two CH devices? We know BGP has many mechanisms to prevent loops. For example, as path. Please pay attention to this. The as path attribute is not transmitted when passing through OM protocol. This attribute is not transmitted. OM protocol does not carry the BGP as path attribute. As we can see, when BGP is announced and redistributed to OM, the as path attribute is not propagated. It is absent. It only has met and origin attributes. At this point, without the as path loop prevention mechanism, looping will occur. How to avoid it? Use the suicides of origin attribute. When OM passes BGP routes, it carries a specific SU attribute. Between two edges, routes with the same SU are not accepted. This is BGP's first loop prevention feature, preventing loops with SU. The second overall method to prevent loops. As we mentioned earlier, OM does not transmit as path. We add a configuration during setup, adding BGP with the same as number. We use the same as number. Because of the same as number, they will not be transmitted. By comparing as numbers to prevent loops. The third scenario is in the OM protocol. We add a comma. When CH devices see we have the same overlay as number, we consider it to be the same site and reject the routes to prevent loops. The fourth mechanism to prevent loops. In the VPN configuration, we add a default condition where the as path is not transmitted. When we add this configuration, the BGP as number can then be propagated. Okay, returning to the traditional mechanisms of BGP to prevent loops, when the same as path is seen, rejecting the route, thus avoiding loops. Earlier, through two protocols, through the interaction of BGP and OSPF with OM, we grasp the patterns of redistribution between them. The first one for OSPF is through the DN bit. The second, for BGP, is through the S number. To allow BGP to pass the S number, we have 4 methods. Specifically, the first is to add the forced transmission of S numbers. The second is to add an overlay as number in the OM protocol. The third is to configure the same as number in the VPN. Preventing loops is very simple. We use the origin attribute to prevent loops for BGP. It has 4 means to prevent loops. Okay. So in this lesson, we covered the configuration of EIGRP, as well as the redistribution between home and traditional protocols. This concludes the lesson.